All right, 0.5a, solving equations. Before we even get started, there's a couple ideas I want you to take note of. There are ways to introduce an extraneous solution when solving an equation. One way is by multiplying each side by a variable, or raising each side to a rational power, meaning you're squaring each side or you're square rooting each side. All right, so for example 1, solve the equation and check your solution. If not possible, explain why. Okay, so what are we going to do here? I want to get rid of the fractions, so I'll multiply both sides by the LCD, least common denominator. In this case, it's easy to see what it is. It's y. All right, so distributing here, the y's will cancel, and I get 17 plus y. Distributing to the second term, the y's cancel once again, and I get 32 plus y. That's equal to 100y. So then I end up with 49 plus 2y equals 100y. Subtract 2y, and I get 49 is equal to 98y. Divide by 98, and y is equal to 1/2. Now that could be an extraneous solution because I multiplied by a variable on both sides of the equation. So let's check that. Let's plug it in. So instead of plugging in a half, because fractions tend to be a little confusing to work with at times, just plug it in as a decimal. So I'm going to do 17 plus 0.5 over 0.5. I'm checking here. Plus 32 plus 0.5 over 0.5 is equal to 100. So I end up with 35 plus 65 equals 100. And I get 100 equals 100. So check, yep, that works. It's not an extraneous solution. All right, what I did here, just to clarify, 17.5 divided by 0.5 is, you get 35. All right, essentially you're just doubling it. All right, for part B, what is the LCD? Okay, well, first thing we need to do is get all the denominators in factored form, and that helps us see what the LCD needs to be. All right, there we go. So what will our LCD be? Okay, well, we have a x in common. We're also going to need an x plus 3 in all of our denominators. All right, now the power behind the LCD. What's so special about it? When you multiply both sides of the equation by it, it gets rid of all the fractions, and that's what we like. So we'll multiply both sides here by the LCD, x times x plus 3. Okay, put extra parentheses around it, or brackets. All right, don't get confused by brackets. Brackets are just a different type of parentheses, just for the purpose of organization. All right, so we're going to distribute here. All right, the x's will cancel out here, but the x plus 3 still remains, so I get 6 times x plus 3. And then the x plus 3 will cancel out here, so I'm left with negative 2x. And then the x plus 3 and the x plus 3 and the x's will cancel out, so I'm left with 3 times x plus 5. All right, distributing, I get 6x plus 18 minus 2x equals 3x plus 15. All right, and combining like terms, I get 4x plus 18 equals 3x plus 15. And give myself a little more space here. Okay, and I'll subtract 3x. Then subtract 18. So I get x equals negative 3. Now typically students will box this answer, all right, thinking that is the answer. to the question. But since you introduced variables into the problem, meaning you multiply both sides of the equation by a term with variables, you may have introduced an extraneous solution. All right, is that extraneous? Well, let's check it. Okay, so let's plug it in. We got 6 over -3 minus 2 over -3 plus 3. All right. And, oops, don't want to put x there. How do I use eraser? Erase. There we go. All right, and I got -3, and then over -3 squared plus 3 times -3. Okay, so right away when we plug these values in, you should notice something. You get 0 in the denominator here. Whenever you divide a number by 0, that's undefined. So -3 can't be a solution to this equation then. This is undefined. You cannot divide by 0. So your answer is no solution. And the symbol for that is a circle with a line through it. And your reason is the solution is extraneous. All right, so watch out for those. All right, on to the next example. Okay, we have to write the quadratic equation in general form. Now, what is general form? General form for a quadratic is ax squared plus bx plus c. All right, now what makes an equation quadratic? The highest exponent is 2. Okay, so to get it in standard form, we have to have the variables be in descending order, and then it has to be equal to 0. So in this case, I'm going to subtract 16x over to the other side. And that's all I have to do here. They just told me to put it in general form. On to the next example. Solve the quadratic equation by factoring. Okay, so we've done this before. Got to find two numbers that add up to -10, multiply to give me 9. That would be -9 and -1. So I factor now. But here I'm working with an equation. It's equal to 0. Okay? So since I'm working with an equation now I could solve for the values of x. I set each factor equal to 0. Just add 9 here. I get x equals 9. And add 1 here. X is equal to 1. All right, nothing more to do there. On to the next example. Example 4, solve the equation by extracting square roots. Okay, in order to get rid of the square here, I need to take the square root both sides to undo that square. So then I get x minus 5 equals square root of 30. All right, common mistake is that many students forget to incorporate the positive and the negative. All right, don't forget that. So now I have positive, negative square root of 30. I'm going to use a prime factor tree and break down 30 into its prime factors. And I don't have any pairs, so you cannot break down the square root of 30 anymore. You can't simplify it. So I'm just going to add 5 over. And typically the whole number comes first, and then the irrational number will come second. All right, and that's all there is to this problem. We're done. On to the next example. All right, solve the quadratic equation by completing the square. Okay, in order to complete the square, the first thing you're going to do is move the constant over to the other side. All right, then you're going to take this value here, which is your b value, and you have to divide it by 2, and then square it. So you get 1 squared, which is just 1. All right, and I'm going to add that value then to both sides of the equation. All right, now by doing that, what I just did is I turned this quadratic here into a perfect square. meaning I could rewrite it as a square. Now, how exactly do you do that? Well, my variable is x, and then what is this value here? Well, I simply just apply the first step that I did over here. I divide by 2. So I get -1. All right, and then on the right side I have 4. And now it's just like the problem we did before. In order to get rid of the square, I have to take the square root of both sides. Don't forget the positive and the negative. I get x minus 1 equals positive negative. Square root of 4 is 2. So I get x is equal to 1 plus minus 2. So let's work out both cases. X is equal to 1 plus 2, and x is equal to 1 minus 2. So x is equal to 3, or x is equal to -1. And then we're done. All right. If you want more clarification for what we did right here, just look at the notes that I have completed, and it outlines the steps for completing the square. All right, on to the next example. Okay, solve the quadratic equation by completing the square. There are a number of different ways to approach this problem, but this is the way I do it. Okay, I already have the constant on the right side. First thing I'm going to do is get the leading coefficient to be 1, so I divide by 9. I get x squared minus 12 over 9x is equal to 14 over 9. All right, now I have to complete the square, but before I do that, I'll simplify this a bit further. Okay, now I'll do it. All right, to complete the square, I need to take this value here, divide it by 2, and square it. All right, when I'm dividing by 2, how does that work? Well, I'll just convert this into a fraction, then multiply by the reciprocal, top and bottom. All right, it's easy as that. So I get -4/6 squared, or -2/3 squared, which is 4/9. All right, so that's the key value that I'll be adding to both sides of the equation. X squared minus 4/3 x plus 4/9 is equal to 14/9 plus 4/9. All right, I completed the square here, so I could rewrite this as a square now. It's going to be x. Now, what's the number that goes here? Well, it's simply the first step for completing the square. I divide that by 2, which gives me -4/6, or -2/3. That's equal to 18/9. All right, and that works out nicely. So I'm going to go up here now. Okay, so now we have x minus 2/3 squared is equal to 2. Now to get rid of the square, you got to take the square root of both sides. Don't forget the positive and the negative. X minus 2/3 equals positive and negative square root of 2. Then I add 2/3 to both sides. I get 2/3 plus minus the square root of 2. All right, and that's about all we can do. You could also find a common denominator, and your answer could be this. So there's different ways to represent the right answer. All right, that's just as right as the first answer that was written. All right, now begin your assignment 0.5a, as seen on the bottom of the webpage.